In this next video, we're going to talk about a type of reaction called a single replacement reaction. It's exactly what it sounds like. One element is going to replace another element. Reactants must be an element in a compound. This is how we're going to recognize a single replacement reaction. We're going to have a single element plus a compound. The products are always going to be a different element in a different compound. So here's an example. Here's an element, sodium, plus a compound, potassium chloride. So if you have two metals in a single replacement reaction, you switch them. So the Na is going to switch places with the K. So the K was partnered up with Cl, but now the K is going to be by itself. So these two will just literally switch, replace one another. So the K gets replaced, it's by itself, and now the Na is partnered up with the Cl. It's important to write your charges always. So you don't need to do it on the reactants because it's kind of done for you, but the products you always need to do it. So the sodium's in group 1, so it gets a +1, and the chlorine in group 17, so it will get a -1. So no need to crisscross here or balance anything, but we might have had to. We don't know that until you do the charges in crisscross. So here's another example, F2 plus LiCl. So this is fluorine reacting with lithium chloride. So if you have two nonmetals in a single replacement reaction, you switch them. So the F2 is going to switch places with the Cl. So the Cl, which was partnered up with the lithium, is now going to get kicked out. And let's talk about the other reactant first. So the lithium, which was partnered up with the Cl, is now going to be partnered up with the fluorine. So the lithium is in group 1, so it gets a +1, and fluorine is in group 17, so it gets a -1, so no need to crisscross. The chlorine is going to get replaced, and now it's by itself. But a chlorine is never by itself. It's a diatomic molecule. It's going to partner up with another chlorine, so it will be Cl2. So this isn't balanced. We need to go ahead and balance this one. Let's balance the fluorines first. So on the left I have 2, on the right I had 1, so I put a little 2 here. And then we balance the chlorines. On the right I have 2 chlorines, on the left I have 1. So I'll put a 2 there, and that fixes my lithiums as well. So there's the balanced single replacement reaction for this one. So metals sometimes replace other metals, and they can also replace hydrogen. So here's an example. We have a metal, potassium, reacting with aluminum nitride. So the aluminum is going to get kicked out and be on its own now, and the potassium is now going to partner up with the nitrogen. So the potassium gets a +1 charge because it's in group 1. And the nitrogen is going to get a 3- charge. Now those charges don't balance, so we need to crisscross. So our final product here is K3N, but this doesn't balance. So the equation needs to be balanced. So I have 3 Ks on the right, 1 on the left. So we'll put a little 3 there, and I believe that's it. We're done with that one. Next, we have zinc reacting with hydrogen chloride. So metals can sometimes replace hydrogen in acids. And that's going to be the case here. So the hydrogen is going to get kicked out. It will no longer be partnered up with the chlorine, but hydrogen is another diatomic element. It's always going to pair up with another hydrogen to be H2. And then the zinc is going to partner up with the chlorine. So zinc has a 2+ charge, and chloride is going to have a -1 charge. Those charges don't balance, so we need to cross the 2 there. I need 2 chlorines to balance out 1 zinc. And then we need to balance. So I have 2 chlorines on the right, 1 on the left, so I'll put a 2 there, and that will fix my hydrogens. 2 hydrogens on the left and 2 on the right. That one's done. So the last example here is when you're doing a single replacement with water. Think of water as HOH rather than H2O. You can even rewrite it to do the single replacement reaction more easily. Metals replace the first hydrogen and then combine with the hydroxide. So here's an example, Na plus water. So we're going to write water as HOH rather than H2O. So the sodium here is going to replace the first hydrogen. So that hydrogen will be kicked out and partner up with another hydrogen diatomically and make an H2. And then this sodium is now going to partner up with this hydroxide, this OH. So sodium's in group 1, so it gets a +1. Hydroxide is a polyatomic ion from table E, and it has a -1 charge. Now my H's don't balance, so I'll put a 2 here to start balancing them. 2 hydrogens plus these 2 hydrogens on the right make 4 hydrogens on the right, and on the left I have 2, so I'll put a 2 there to have 2 times 2 or 4 hydrogens on the left. The oxygens balance. I have 2 oxygens on the left and now 2 on the right, but the sodiums don't. I have 2 sodiums on the right, only 1 on the left, so I'll fix that with a little 2 there. We can even tell whether or not a single replacement reaction will happen at all, because some chemicals are more active than others. You can't just mix any old element in with a compound and have a single replacement reaction happen. It has to obey what was called the activity series. More active elements replace the less active elements. And there's a reference table for this. It's table J. It's called the activity series, and it's pretty easy to use. So there's what table J looks like. The concept is really simple. The higher on the list is going to replace the lower on the list. If you're trying to replace something and you're not higher on the list than the thing you're trying to replace, the replacement will not happen. So metals can replace other metals provided they're above the metal they're trying to replace. Same goes for the nonmetals, the halogens you see on the right, this much smaller list. The idea is the same. Higher on the list will replace the lower on the list. Metals above hydrogen can replace hydrogen in acids, and metals from sodium upward can replace hydrogen in water. So here's our first example here. So the first thing you do when you get to a single replacement reaction is you have to check table J to see if this reaction will even happen at all. So in this reaction, I have sodium chloride reacting with fluorine gas. So this F2 is trying to replace this chlorine. So we need to check, is this even possible? Will this reaction even happen? So the chlorine is in pink here, and it's trying to be replaced by the fluorine, which is in blue. So the fluorine is higher on the list than the chlorine, so this reaction will happen. So let's go ahead and do it. We'll switch the two nonmetals. So chlorine is going to lose its partner in sodium, but remember chlorine's diatomic, so it will be Cl2. And then the sodium is now going to partner up with the fluorine. Sodium is a +1 and fluorine is a -1. This doesn't balance, so let's balance the fluorines first. We'll put let's balance the chlorines first, I guess. 2 chlorines on the right and 1 on the left, so we'll put a little 2 here. And our fluorines aren't balanced and our sodiums aren't balanced. This is an easy fix by putting a 2 there. Okay, next we have magnesium chloride plus bromine. So again, we have another nonmetal single replacement reaction. This bromine is trying to replace this chlorine. So here's bromine in blue and chlorine in pink, and we see that bromine is lower on the list. So this reaction will not happen. Throw all the bromine you want into this reaction. It does not have the electronegativity to compete with chlorine. So chlorine is just going to hold on to its partner magnesium here, and bromine won't react at all. So this is no reaction. Okay, let's do some practice problems here. So this first one, we have iron plus copper 2 sulfate. So the first question you need to ask is, will this reaction happen? And you do this by checking table J. You decide whether or not the element that's trying to replace the element in the compound is more active than it or not. And if it is, go ahead and solve for the products. And don't forget to write charges, crisscross, and balance. And if the element is not more active than the one it's trying to replace, this reaction will not happen. So go ahead and give these a try. The first one will happen. This iron, where is it? Right here, is higher on the list than copper. Copper is almost the lowest on this list. So iron will replace copper in copper sulfate. So the copper gets kicked out. It's now on its own as a copper atom. And the iron is going to pair up with the sulfate. So we actually have no way of knowing what type of iron it is. To make our life easy, let's pretend it's iron 2, so I don't need to crisscross and I don't need to balance here. If it was iron 3, we would have to do some balancing. Next, we have Pb, lead, plus KCl, potassium chloride. Okay, let's see if this one will work. Pb is, where is it? Right here. And it is trying to replace potassium, which is way up here. So there's no way that lead is going to take the place of potassium in this example. So this is a no reaction situation. Next, we have aluminum plus hydrogen chloride. So aluminum is here, and it's trying to take the place of hydrogen, which is down here. So that will happen. So the hydrogen will lose its partner in chlorine, so it'll be H2 because it's diatomic, and the aluminum will partner up with the chlorine. But aluminum gets a +3 charge, and chlorine gets a -1 charge. So we're going to crisscross those charges to balance them. I need 3 chlorines to balance out 1 aluminum, and then I need to balance. So I need to balance this correctly. It's going to require a 6 over here, a 2 over here, and a 3 here. So 3 hydrogens, or 3 times 2 is 6. That's why I need a 6 here. And 6 chlorines. 2 times 3 is 6 chlorines. And 2 aluminums. I need another aluminum here. So there's 2 aluminums. So in a single replacement reaction, one element replaces another element in a compound. The reaction will always look like this. A plus, A is our element, plus BC, B is a compound, will give us B, a different element, which came from the compound, and AC, a new compound, which is a combination of the element and the original compound. Single replacement reactions are based on the activity series, table J. Remember, to determine whether the reaction will happen at all, the element that's trying to replace the other element in the compound has to be higher than it on table J.